Yeah, hi, good afternoon, good evening, good night. Everyone, welcome to my channel, Freaking IT. So today topic is IP. So I believe everybody heard the topic of IP, because you know that when you're doing troubleshooting, everyone say that your IP is not reachable. You need to troubleshoot why the IP is not coming, destination not reachable. So we can discuss what is IP. IP is full form is Internet Protocol. So IP stand for Internet Protocol as a you are able to see my screen. A fundamental protocols for TCP suite that govern how data is sent and received across the network. So IP is also provide you unique ID in all over the world. If I'm doing the comparison of public IP and private IP, public IP is unique in all over the world, and they provide your organizational unique ID. So IP are two types. One is IPv4 and IPv6. If I'm talking about the IPv4, I uses the 32-bit address. The size of IPv4 is 32-bit address. If I will go to the IPv6 using 128-bit address. So there are some interview questions they will ask what is the bit size of IPv4 and IPv6. So you will get more clarity by reading this using 32-bit and 128-bit. IP is a connectionless and unreliable on its own. It doesn't guarantee of deliver order and error checking. That's why it's often paired with TCP or UDP. So TCP and UDP are the part of transport layer in the OSI. So TCP stands for Transport Control Protocol, UDP is UDP Data Protocols. So what is an IP packet? Let now, because the IP is not working individually, they required some other subordinate, or you can some other content to combine. So we need to understand what is an IP packet. An IP packet is structured unit of data that travel across IP network. Think of it as a digital envelope containing both the message and addressing. Suppose if you are sending mail to somebody, you are typing anything inside the mail. So same thing like the IP packet is also traveling, but IP packet has some content we are going to discuss, like header. What the IP header? Somebody asks you what the IP header contain for routing and delivering. So first, IP header contain the version. Are this IPs belong to IPv6 or v4? Are the source address from where this packet was generated, and what is the destination IP where it is going? TTL, time to leave, how much time to travel from source to destination. I already make one video specially dedicated for the TTL. Please watch that. You will get more clarity. Protocols. So in indicate where the payload is TCP or a UDP. See, if let me little bit dig more about TCP. TCP is a three-way handshake and more reliable than the UDP. UDP is a connectionless. So if you want to dig more, please read the OSI layer. I have another video for OSI layer. Please go so that you will get more clarity on the TCP UDP, because in this world there are two type of transport protocol layers are there. One is TCP and another one is a UDP. There's checksum. So checksum, that validate the header integrated. Are this header is coming from the right, so integrate is fine. You can say the authentication is fine. Another part is the IP packet is a payload. The actual data being transmitted, part of webmail. So payload will carry all the information, and this is a part of page, email, video stream. Payload, the payload, how we can travel the payload, the encapsulated data, encapsulated data from transport layer, either it is from TCP, I will already discussed, or UDP to the destination. Size vary depending on the application and network constraint, because you see that sometime you heard the one thing like MTU, maximum transit unit, by default how much. Sometimes some application you need to reduce the MTU, but in this is a IP. We are going to discuss another part, the more structure of IP header. Again, the IP header contain main part. So if somebody asks, in IP packet consists what? The two main parts. One is header, one is a payload. The header contain again metadata and routing information, where need to send this, where need to go, what size. Payload actually contain that transmitted, if it is a TCP or UDP. I am giving very simple example. Suppose you guys are listening radio, in radio or something, that is a UDP, is a connectionless, because there is no guarantee for delivering back. But TCP IP packet, they are three-way handshake. Yes, there is a three-way handshake, and it is a little bit, if I mean speed wise, slower than UDP. Okay, come to the topic version. We last slide we discussed 4-bit. It's a 4-bit indicate the IPv4 packet. There is a IHL header. Header. So header. What is the header bit? Somebody asked you that what is the IHL header bit in the IP header. So it's a 4-bit length of header in a 32-bit words. Type of service. So type of service cover 8-bit. So specify priority and handling delay throughput. Sometime you need to give the priority to voice traffic, some web application. So this is a type of service you can indicate the packet which specify handling. Total length. So and the rest of header is 16-bit. Total size of packet header plus payload. It also cover header plus payload. So some people ask you question that what is total length of your IP header, and what two main parameters are carrying. One is header and plus payload. Identification also is 60 bit, which provide you unique ID for packet resembling it fragmenting, because otherwise we are not aware that packet is coming from where, and it will go to where and receive back. There is one more thing, this is a flag. It is quite important. It's carry very small bit, 3-bit, but control the fragmentations. So example, the packet don't fragment, it will go proper way. There is one more thing which is the, if I will dig for more fragmentation, is a fragment offset, which is a 13-bit in the packet, which position of fragment in the original packet, that which packet will go further, and how this, what is size of fragmentation they do. Time to live TTL, which is cover a 8-bit, limit the packet lifespan to infinite loops. So if there is no TTL value in the packet, the packet will travel all over network, because in the TTL value defined, this packet can travel only 20 hop, 50 hop. By default the window is 255 hop. After the packet will reach to 256 hop, the packet will discard it, and the user will receive the message ICMP unreachable. The another one is protocol. Protocol carry the 8-bit field, indicate the next layer of protocol, either TCP or UDP, which protocol currently going. The header checksum is cover, the header checksum is also one column which is 16-bit error checking the header. If there is a header error, something the packet is not delivering. So means something, some device is generating wrong header, or we are sending packet to wrong thing. It will come on the header check. When you do the any Wireshark or anything, you are able to find the header check. Now another IP, another field is which is 32-bit, which is source IP address. Source IP address is from where this packet was originating and where it is going. The destination IP address again 32-bit, where the receiver IP address is there. Option variables. So what the option variable, like a security, time span, which packet it pass from which node, it will get clear exact picture. When if you want, if you know to troubleshoot the IP header by the Wireshark mallocs, you are able to troubleshoot anything, because the IP header will give you all the information which we require for troubleshooting. So thank you for watching this topic. I am going to explain more detail in the IP packet in my next video. So please stay with me, or kindly request, humble request, please subscribe my channel so that I will make more video. It will really motivate me and get some more information to share with you guys. Thank you. Thank you. Welcome to